Hello and welcome to a new video. This is Mo from APC Mastery Path, and I'm glad to be sharing with you in this video how you could prepare your data for fine-tuning your large language models using Unsloth and also using Marker BDF library. In this video, we're going to be showcasing the main concept itself and how to make it work, and then we're going to be jumping to Marker BDF package and presenting a deep dive into that package. And lastly, we're going to be showcasing briefly how you can use the resultant training data to train and fine-tune your desired large language model using Unsloth. If you are new to our channel, do not forget to like this video and subscribe to our channel and press the bell icon to get a notification with all the new tech videos that we provide. And now, without further ado, let's get started. So the main concept is to have text files. You extract the text from these files and save it in a format that is understood by the large language models, and it gets easy to fine-tune them. The example I'm going to be showing you in this video comprises a PDF document, which I'm going to be using one of the packages called Marker PDF to extract the text from that document. And then the extracted text, we're going to be analyzing the structure of it, and we're going to be using Python to convert that extracted text into a format that is understood by large language models, and the final output is going to be the fine-tuning dataset that is going to be used with Unsloth, a technique to fine-tune our desired large language model. Having understood the main concept of the solution, it's now time to dig deeper into the actual building of this solution. We're going to be using a package called Marker PDF. The repository is on GitHub. I'm going to be putting the link in the description below the video, and when you open it, you're going to be greeted with this website or with this web page, which includes all of the folders and files that helped build that Python package or library. It includes a brief description about the package itself, the limitations, how to make it work, the accuracy measurements, and other bits and pieces. The way to install the package, we're going to be digging deeper into that in a bit. So the first thing is, I created a folder and I called it bars PDFs faster. This folder, it contains the data or the PDF files that I want to convert, and I went to VS Code and then I clicked on file and then open folder, and then I chose the folder itself and then I opened it. And as you could see on the left, I have the data folder which includes all of them files. It's now time to create a virtual environment. You can call it however you please. I called it bars PDFs. So the way to do that is go to terminal and then new terminal, and then to make it easy for the eye, I'm just going to click on PowerShell here and then move terminal into the editor area. And then if you clicked on PowerShell and then drag it to the right here, and then let's type in some code so that we can build the virtual environment. So the first thing is Python M and then venv virtual environment, and then the name of that virtual environment. Once you click that, it's going to create a folder here like that one, parse PDF. For me it was parse PDF only, and it created that folder and files and folders beneath the main folder. In order to activate your environment, you would simply write its name. So for me it was bars_pdf and then backslash and then scripts, which is that folder here, and then there's a file called activate, backslash and then activate. Then if you clicked enter, you will find that here the active environment is the bars PDF. You can also do it through Conda if you have Anaconda installed. In my case, I do have Anaconda, but I prefer to create it using the virtual environment method. If you're using Anaconda, it could be Conda and then create and then the name of the environment, for argument's sake that one, it's called PDF. And then you can also refer to the preferred Python version that you want, if it's 3.10 or 11 or the likes. In my case, the Python version that is installed on my system, you can know it using Python -- version, and for me it's 3.11.5, which is the same version that has been allocated to bars PDF. You now need to install the package, the main package or the main hero of this story, which is, you can install it using pip install and then marker-pdf. I've already installed it on my machine. I have noticed something, that by default it installs Torch with CPU support only. In my case, I do have an NVIDIA GPU, so I would like to have CUDA support. So in order to do that, I went to the pytorch.org website, and then if you scroll to the bottom of it, there is you can choose the stable version and then whatever OS you have. In my case, it's Windows, and then I'm going to install it using the pip command, and then for the programming language of Python, and then I want to have CUDA 12.1, and you can copy that, Control C, and then go to your terminal and then Control V, and then it's going to take some time because it's going to download about 3 gigabytes of data. So, having installed MarkerBDF, it's now time to explore its capabilities. MarkerBDF can either convert a single file or multiple files. Let's understand together the code for it. So if you want to convert a single file, you can type in marker_single and then the path of the file .bdf, and then the path of the output file, or where the converted files are going to be sat, or where the converted extracted text is going to be sat. And then the batch multiplier, the more you have or the more you dedicate, the more VRAM there's going to be required. And then there's also an argument of the maximum amount of pages that you want to convert if you have this kind of limitation. And then it contains a number of them languages that are supported. In my case, I kept it quite simple, marker_single, and then the folder called data. The file was file6.bdf, and then the output is converted _bdfs, the converted or the file where the converted text is going to be sat, and that's basically it. I pressed enter, and I will show you in a bit what happened. So if you could see here on the left, there's converted BDFs. When I opened it, there's file6, and it's showing a number of them images that have been extracted as well from this text. That's because the nature of my BDF is as follows. So let me show you the original BDF file. When you go and click on file6.pdf, it's my submission for the RICS APC. As you can see here, there is a watermark, and this watermark was understood to be some sort of like an image. Plus, I do have some notes that I was putting in the file itself for the studying and the likes. And the structure of this file is that I do have 3 different types of competencies, or 3 different categories: the mandatory, the optional, and the core. And below each and every single category of competencies, there are different names or types. For argument's sake, that is diversity, inclusion, or whatever it is, and then there's ethics, and so on and so forth. And then beneath each and every single competency, there is a level. So level 1 is knowing, level 2 is doing, and then there is a 3rd level, which is advising. And then there is below that the summary of experience under that specific level. I'm explaining this because I'm going to be using it later on when we're going to be showcasing or exploring together the code that I have drafted to convert the extracted text into a format that is understood by large language models. Having understood the structure of that BDF, let's explore together the converted text after we typed the code on the right. So if I go to converted BDFs and then file number 6, you will find that there is a file called my submission and then .md. MD is markdown. So if you clicked on it, you will find that the file is a bit of a mess, but there are some data that is easily extractable from it. So it's mandatory competencies, and then the name of the competency, and then the level, and then the summary of experience. And then if you scrolled inside your BDF, you will find that there are some references to some images. In my case, the images, there isn't any images really, it's just the watermark. I did some basic cleansing in order to make the document easy for the eye, or the markdown file easy for the eye, which I did here. So mandatory competencies, what is the competency? I just pressed enter, nothing major. It took me about a minute to do the whole file, a minute or 2 minutes, and now the file is in a very good shape, and I'm going to be doing further cleansing on it, which I'm going to be showcasing to you in a bit. As we have explored together in the code itself, or the documentation, let me go back to it. So here you will find that there is conversion also of multiple files. It works exactly the same, there's just a little bit of a difference. So let's explore together the code itself. So marker, because that's the name of the package, and then the path to the input folder, and then the path to the output folder. Worker is how many PDFs are going to be converted at the same instant, and then here is maximum number of PDFs to be converted. And then if you want to save the metadata related to the PDFs as a JSON file, and the length is the length of the characters, the minimum length of the characters to be converted. In my case, I kept it quite simple, just marker and then the path to the input folder, then the path to the output folder. And the way to do that is marker, and then for me it was data and the converted PDFs. And that's all about it really. So I'm going to be focusing more on the conversion of a single file, but the conversion of a single file is the same as the conversion of multiple files. That's not going to be a huge problem. So going back to the partially cleansed file or markdown file, I created a Python code for it. So first of all, I imported the regular expression because that's going to help me to delete some characters and split the text and the lines. I also imported the JSON because my final output is going to be in JSON format or JSON lines format. The tcenter is it was optional. I preferred to make my code a little bit more flexible. tcenter allows the end user to have a dialog box to choose and do some actions from it. So in my case, I created a function to choose multiple files, multiple input files, to be converted into JSON, and the multiple input files, they're going to be saved in one output file in whichever location the user wants. So that's why I imported the tcenter library. And then I did some cleansing because I had a draft not for assessment and not in that way, not assessment for assessment, and these were scattered all over the text or the markdown file. And then I had an idea of using the architecture of this file. I will have 3 different levels that I'm going to be focusing on. So the first level is the category of the competency, and the second level is going to be the name of the competency, and then the third level is going to be the actual level that I want to write in. And that's what I did in the next portion of the code. So I created an array with all of the text, and then I began the separation into level 1, 2 and 3. Level 1 is going to be the competency group or the competency category. Level 2 is the name of the competency, and level 3 is each level in the competency. And in this portion of the code, what I did was I had a template of the conversation in mind, and I wanted to make it as lively as possible. So the human being or the person is going to be asking the bot that they want to write about a specific competency, and then the bot could answer by saying that, yeah, I can help you with that, which level are you seeking? And then if the person is not knowledgeable enough, they're going to be asking how many levels are there in this specific competency that I'm asking about. And then the bot can answer that based on the data that I do possess. The last level or the latest level is X, for this competency is X, and then the person could ask for help in any level that they would require, whether it's level 1 or 2 or 3 accordingly. And then the bot is going to be providing the final answer required by the end user. And then lastly, it's all about collating everything together in a huge function that is going to call up all of the other functions. Again, this code is not going to be relevant to each and every single person. It was quite relevant in my case because of the structure of the data that I had, and I'm going to show you now the end result. So I saved it here, and it gave me that JSONL file, which is quite decent, to say the least. And here is the converted file, which is in a JSON line format. It's composed of 37 entries, which is for this specific submission. So the human is going to be, I want to write about a specific competency, and then the bot is going to be answering, and then the bot is going to be saying that based on the information that I do possess, the latest level is level 1, and yeah, could you help me write with level 1? And then yes, go forward. For me, the test was in an area like ethics. I have 3 levels, so could I make it work in 3 levels? Okay, so it worked because I have in this competency the last level or the latest level is level 3, and I do have 3 examples, one for each level. So here, sure, here's a proposed response for level 1, here's a proposed response for level 2, and here is a proposed response for level 3, and so on and so forth. And the end result is really good. As you could see here, look, we can even convert it back to a JSON line format. So I have 37 entries for the whole of my submission, and yeah, it took me some time, but the RICS APC submissions, they are quite systematic, so I'm not going to be developing that code again. I'm literally going to be running that code for each and every single person who has an RICS APC submission. So having extracted and converted the data in a JSON line format, it's now time to use this data to fine-tune your desired model using Unsloth. I have made previously a detailed video about how to use Unsloth on your machine locally to fine-tune your desired models on customized datasets. I'm going to be showcasing how you could do that briefly. So Unsloth allows you to fine-tune large language models, a variety of them actually, Llama, Mistral, Phi and Qwen, and it's much faster than the old methods. You need to have some stuff in place. So the first thing is you need to have Windows subsystem for Linux, because Unsloth does not run Windows, so you have to have Linux or Windows subsystem for Linux. And you can open PowerShell and type in wsl install, and it's going to install Windows subsystem for Linux version 2.0. The second thing that you need to have as well is Anaconda, so that you can run all of them codes in Anaconda environment. So the way to do that is you can go to the link which I'm going to be putting in the description below to the main site of Anaconda, and then you can download whatever version you will please, and then you can install it using the code that I'm showing you here. Make sure that you are changing the word version with the actual version that you download. In my case it was 2024.02. The third thing that you need to have is Unsloth, and I have followed the installation procedures provided by the Unsloth team on their GitHub repository. So basically you create an environment called Unsloth environment with Python 3.10, and then there are some packages that you need to install, such as PyTorch with CUDA enabled, the CUDA toolkit as well, Xformers, and then you need to activate the environment itself. And then lastly, you need to download lots of them packages from the Unsloth repository, and you would need to install Hugging Face, Hub, Beft, which is parameter efficient fine-tuning, accelerate bits and bytes, and weights and biases. I have found out that there are some problems that might arise from this approach, so I have downloaded the torch with CUDA enabled from the pytorch.org, as I've shown you at the beginning of this video. Also, I had to install the NVIDIA CUDA compiler or the NVIDIA toolkit. I've searched online. I'm going to be putting the link in the description below, and basically you're going to be copying these codes inside your environment, and it's going to run like charm. And then let's run through the code quickly, because I've already explained it thoroughly in my other video, which I'm going to be putting the link in the description below. So importing some necessary packages such as Torch, and then supervised training, transformers, datasets, and also importing Unsloth main package. The main thing that is going to differ from my previous video is the actual format of the dataset. So there is a library called load dataset, which allows loading the datasets in a format that is understood by the large language models. So instead of having me here CSV file path, it's going to be the JSON file, that one. In the load dataset, that CSV is going to be JSON, and the data files is going to be the JSON file path. And definitely you'll have to have some sort of like train data and testing data. So instead of the delimiter, it's going to be split, and then the equal is going to be by train. The remaining part is not going to be used in this code because I've used it with a CSV file. It's going to be different now because the JSON is already in a very good shape. This code that I have used here was used with a CSV file that wasn't in the same shape. The next step would be importing your desired model. Unsloth, they have a very rich repository on the Hugging Face website, which contains a lot of the models, instruct models and base models. In my case, I imported the Unsloth Mistral instruct model, version 0.3. There are other bits and pieces like Llama, Qwen, Phi, both in base and in instruct variants. You can import whatever you please. Having done that, I did some sort of like a function to test the model pre-fine tuning, and I'm going to be comparing the performance pre and post fine tuning. So here the function is quite simple. The inputs, tokenizing them inputs, and then decoding the inputs into outputs, and then printing the decoded outputs, and then asking the model a very simplistic question and see the response pre-fine tuning. Moving on, you'll have to initiate the low rank adapters by targeting specific modules, and you'll have to play around a bit with the parameters according to your use case. In order to use Unsloth, you'll have to have a weights and biases key. In order to do that, you'll have to go to the website WANDB, which is weightsandbiases.ai, and then you create an account, and then you get a key, and then you paste the key after you do the login. Having done that, you'll be able to manipulate the training parameters to suit your needs. So here I'm importing the model, and then the training dataset, that's the dataset up above, and it's split by train. And then the key to that dataset is text, and then the tokenizer is going to be the one from Mistral. The maximum sequence length, that's the 2048, which has been already defined at the beginning of the code. And then you can manipulate the training arguments, such as the maximum number of steps for training of the model, warm-up steps for the model, in order to get into shape, and also where you're going to be saving it, what optimizer you're going to be using, and how many logs you want. And that's going to be quite relevant to how many checkpoints you need, and if that's going to be of any importance to you. Having done that, it's now time to train. So trainer.train, and then you're going to leave it a bit. It's going to take from you anywhere between 30 minutes to an hour, depending on the data set, depending on your infrastructure as well, the GPU and the likes. And then moving on, it's now time to test the fine-tuned model. So using the generate text function that we created up above, we asked the same question to the fine-tuned model, and it's now time to compare and contrast the performance pre and post fine-tuning. And lastly, it's now time to save it, whether you want to save it locally or on the Hugging Face website. If you want to save it locally, you can use model to save underscore pre-trained, and that's going to save the LoRa adapters only. If you want to save the LoRa adapters on top of the fine-tuned model, then you'll have to use the save underscore pre-trained underscore merged, and then the folder where you're going to be saving it, and make sure that it's merged 16-bit for the saving method. If you want to save your model on the Hugging Face website to be used elsewhere, the process is quite straightforward. You'll be logging in, and if you have to have an access token with right privileges, and then you're going to be identifying what is the directory of saving the LoRa or the model, or both. And then lastly, you're going to be pushing the model to the hub, and that's going to push only the LoRa. And if you want to push the fine-tuned model itself, then you'll have to use push to hub merged, and then you're going to be identifying what is the directory and the merge 16-bit as the save method. Make sure that you have an access token generated with right privileges. That's all for today's video. Thanks a lot for watching. Hope you find it useful and insightful. Do not forget to go and watch our previous videos about fine-tuning of large language models and creating customized chatbots using custom datasets. Do not forget to visit our website www.apcmasterypath.co.uk. At APC Mastery Path, we provide bespoke mentoring and teaching packages to RICS APC candidates. Thanks a lot for watching. Catch you in the next one. Cheers, guys.